Right, so we're going to take you very quickly through esters, carboxylic acids, and alcohols as well. Hopefully, by the end of this, you should have an idea how an ester is made, what the different acids and alcohols are, and just how to name the basic ones that are present on the screen at the minute. So we're going to make a start. Alcohols are these guys over here, starting with methanol. Methanol is your simplest, smallest alcohol. It's one carbon chain in length. That builds to ethanol, propanol, butanol. Don't worry about the butan one or the propan one. For you guys, it's just going to be propanol tomorrow, and butanol. If they ask you in the exam what is the functional group, then hopefully you'll recognise that the OH group is the functional group of this alcohol. They all have that in common, and because they've all got that group, they all react in a similar way due to them having that OH group present. Now, most of your alcohols that you know will be in drinks and things, and generally speaking, ethanol is the alcohol that's used in drinks and beverages. The rest of them have other uses as solvents and sort of in cosmetics and stuff and making various things. But generally speaking, the main one that we consider as a useful one is ethanol for drinks. Right, moving over to this side, we have carboxylic acids. Now, carboxylic acids are a little bit trickier. What they have is a characteristic group which is C, double bond, and then an OH. Now, sometimes you see that written as like COOH, which some people say, oh, that's cool. That's the carboxylic acid functional group. So if you're in the exam and you're asked to highlight that group, it's basically this part of the molecule here. So that is the functional group that makes an acid a carboxylic acid. Now we refer to carboxylic acids as being weak acids. Now most people um, will have seen that phrase in their revision guide, which basically means that they they don't fully dissociate. That's the term you want to be using in the exam. So if you ask tomorrow what a weak acid is, it's probably best to write they only partially dissociate, which is one of the reasons why we class them as weak acids. So all of these acids are all, again, from the same family. They get bigger in terms of number of carbons as we go down. And generally speaking, the first four, that's all you really need to know for C3. So we've got alcohols, carboxylic acids. Well worth knowing the structures of all of those. If you don't know them, make sure you can name them, make sure you can identify the functional group, which we've circled here, and also make sure you can draw them out. In the exam, if you're asked to draw, just as a quick aside, if you're asked to draw the displayed formula of a carboxylic acid, they will use that phrase in the exam. Make sure you draw the bond in there for the OH. Don't just go C double bond O with no line in between there, because that will lose a mark. Right, making esters. This causes problems every year because most GCSE students haven't really done much organic chemistry. Organic chemistry is essentially the study of carbon chains and carbon molecules. Now what you've got when you make an ester is you use a carboxylic acid and you'll use an alcohol as well. Now, in order to do the reaction, you need to use concentrated sulfuric acid catalyst. You just need to remember that, and that's used in order to remove the water from the reaction and allow you to make your ester. Now, the first thing I'm going to say on this is to make sure you're able to do it. It's essential that when you start to draw the structure, that you actually make sure that you've got your two OH groups, which you can see there, my alcohol OH group and my carboxyl group. Make sure they're facing each other, because what's going to happen in a moment, the alcohol is going to lose the H that it's got, and that's going to disappear, and the carboxylic acid is going to lose the OH that it's got. Now, once you bring them together and you lose the two H's and the O, that essentially makes H2O. And that's your water being produced from this reaction. Then what happens is this bond that was previously joined to the OH makes a bond over to this O. Now, in an exam situation, you wouldn't leave your diagram drawn out like that because it's obviously incomplete and it looks a bit ridiculous. So what you do is you then draw it out in the correct way. So you draw your C double bond O, which you've got, and then a bond, then your single bond O, and then your two C's over there, and then you just fill them up with hydrogen atoms, and just ensure that each carbon atom is making 4 chemical bonds. If you do that, then you'll be fine. Now the problem is this ester that I've drawn on the screen. In terms of naming that, esters are named in a very, very specific way. Now, what you tend to find with esters is people see the name and think, well, I'm not sure how that name's or where that name comes from. You see this ester is named ethyl propanoate. Now, I'll explain why that is in a sec, but ultimately, the alcohol forms the first part of the name. So when I see ethanol, it's going to always form ethyl something. So if I'd have changed this alcohol to propanol, this ester would become propyl propanoate. If I'd have made the alcohol butanol, then the ester would have become butyl propanoate. Now the second part of the name, that comes from propanoic acid. So the propanoate is called such because the acid I've used here is propanoic acid. And if I decided, okay, I'm going to use butanoic acid, then the ester would become ethyl butanoate, and it would have a different name. So the way to identify that in an exam situation, if you're sat there in the exam and you think, oh, I'm not sure, by looking at the actual molecule itself, I'm not sure which part is which, you just look at which line the double bond O is on. So if you circle this bit here, the double bond O, the C double bond O, which is this bit, is part of the 3 carbon chain, and that's why it's propanoate, whereas the other bit, the 2 carbon chain, is the ethyl. So if I was in the exam and I saw this ester, just for the sake of time, I'm not going to draw every hydrogen on. If I saw that in the exam, I'd look and think, right, the double bond O belongs to the O8 bit, so this is going to be butanoate, and then this part is going to be from the alcohol, so that's going to be methyl. So the actual name of this this ester I've drawn here would be methyl butanoate, and that's the name of it. And you can do that if I decided, okay, I'm going to change that and I'm going to get rid of this carbon here, then the name would become methyl propanoate. If I get rid of that, methyl ethanoate. If I decide to myself, okay, I'm just going to extend this carbon chain down here, I'm now making ethyl ethanoate, propyl ethanoate, and so on and so forth. So hopefully that's cleared up a little bit about esters, alcohols, carboxylic acids. The main thing to note, make sure you know your carboxylic acids, make sure you know your alcohols, make sure you know how to make an ester, that you use a carboxylic acid and an alcohol. You use concentrated sulfuric acid catalyst to remove water, and know how to make the ester, draw the ester, and ultimately how to name it. If you ask for this in a reaction, it's just a reversible reaction, so you'd have them two at the top would be your reactants that make the ester and water as well. So in an equation, you just draw them in, and that would be an actual equation. But they're going to be more interested in the structure. There's one other thing. Make sure you're also aware that the esters functional group is this part of the molecule here. So all of this, with the C double bond O and the single bond O, that's the functional group of the ester. Generally speaking, esters are sweet smelling. They're used in perfumes, they're used in flavourings and fruits and things like that. And that's because they have a lovely sort of nice sweet smell. Pears, apples, them kind of fruits, they've all got esters in there. Hopefully that's helped and made life a little bit easier for esters, carboxylic acids and alcohols.